day grade 11s, my name is Miss B and this is Miss B's Hive, and in today's video we will be discussing electronegativity. So first of all, you need to understand where we're going with this lesson. So we will be discussing what is electronegativity. We will be looking at electronegative elements, periodic chains relating to electronegativity, and finally we will be calculating bond polarity using electronegativity values. So first up, I have defined what electronegativity is. Because this is a new topic for grade 11, it is important that you understand or know how to define electronegativity. So it is the measure of tendency of an atom in a compound to attract the shared pair of electrons, or you can say to attract the bonding pair of electrons as per your examination guideline. So I want to point your attention to fluorine. Now, fluorine is the most electronegative element on the periodic table. And as we move towards fluorine across a period, the electronegativity will increase. Right? And as we go down the group away from fluorine, the electronegativity will decrease. So that is a quick way of remembering the trend. As you move across a period towards fluorine, the electronegativity will increase, and as I move down the group away from fluorine, the electronegativity will decrease. Now, the examples of electronegative or highly electronegative elements will be your nitrogen, oxygen, and fluorine. So that's NOF. And that is how we will determine, as we move towards those elements, the electronegativity values will be higher, which means that those elements attract the shared pair of electrons more closely, creating something called a dipole or a dipole moment. And there's an unequal sharing of electrons, but we'll discuss that on another video. So next up, we will be doing Pauling's electronegativity values and looking at how that determines bond polarity. Alright, so now that we know that the electronegativity is the tendency of the electrons to be pulled, the bonding pair of electrons to be pulled by one particular element in the compound, we are going to calculate the electronegativity difference. Now, from the word difference, it comes from mathematics, meaning subtract. And in calculating the electronegativity difference, I have to use the larger number minus the smaller number. So I'll do some examples with you, but this is to avoid getting a negative electronegativity. So it does not mean that the name is electronegative, that the answer should be negative. You should be getting a positive answer. All right, so now that we understand how to calculate it, I'm going to do some examples with you. So I've inserted a table here which gives you the electronegativity ranges and the type of bond that will form. Now, this is very important for you to remember, grade 11s. So I would suggest you write NB and remember this table. It is very important to explaining bond polarity as well as determining it should the question in your exam ask you to do so. So we're going to start with the first type of bond, which is non-polar covalent or covalent. Now, these exist between diatomic molecules. Now, that's the only way that you would get a 0 as an answer. Now, my examples of diatomic molecules are hydrogen, the gas, nitrogen gas, oxygen gas, fluorine gas, iodine gas, chlorine gas, bromine, just to mention, those are 7 elements, and they form the 7 on the periodic table. So if you would like to remember it, it would be these 7 here, as well as hydrogen over there, which is also a diatomic molecule. Now, In calculating this, we will see that when I look at my Pauling table, I will have an electronegativity difference of 0. Alright, so some examples of how to calculate the electronegativity difference. We're going to start with diatomic molecules. So let's say O2. So I'm going to write the change in electronegativity, and I'm going to look at my table and read off the electronegativity values. Now O2 has an oxygen bond. So despite the fact that there's a 2 there, you're going to look at which atoms are bonding. So I have 3, 5 minus 3, 5, and that gives me 0. So I can see, looking at this table, that it is a therefore it is a non-polar covalent bond. And that's how you determine the electronegativity difference. Next up, we're going to look at H2. So that's hydrogen diatomic. You will write down the En difference is equal to 2, 1 minus 2, 1, and that will give you a 0, which means it is non-polar. Now, this non-polar that you see here is the bond polarity. So there is molecular polarity and bond polarity. So whatever you're going to calculate using this electronegativity values on your periodic table, you will find the bond polarity and not the molecular polarity. That is something completely different. Right, let's try for N2, which is nitrogen. It has a nitrogen-nitrogen bond. That's the Cooper model. And it is 3, 0 minus 3, 0. I'm just going to erase that so that you can see. And then that will also give me 0. So I can see when it is a diatomic molecule that the electronegativity difference is 0, thus making it a non-polar covalent bond. So that is very, very important. So you can actually cram this and remember that diatomic molecules, or when an atom is bonding to itself, will result in a non-polar covalent bond. And that is its bond polarity. So if you are asked to explain, it is always in your best interest to use these En values to determine what the bond polarity is in your explanation. And then remember, this table I said is extremely important, and you need to remember the different ranges that result in from your electronegativity differences. All right, so next up we're going to look at the just regular covalent molecules and determine what type of bond. All right, so next up we're going to look at different substances that are still covalent, for example CO2 as well as HCl, and I'm also going to use NH3. So first of all, we need to understand that in carbon dioxide there is a carbon double bond to two oxygens. So the bond that I'm looking at is the carbon double bond oxygen bond, right, in this particular molecule. So when calculating the electronegativities, I'm just going to need the two elements between which the bond occurs. So the difference in En is equal to, now carbon is 2.5, oxygen is 3.5. We start with the biggest one, 3, 5 minus 2, 5, and the answer is 1, no unit. And if I look at this table, that means that I have a what we call a weak polar covalent bond between this. Right, now bond strength of double bonds and single bonds is another topic on its own. So essentially you have to look at the compound and see which elements are there and the bond which occurs between them. All right, so let's look at the next one. So for HCl, which is hydrochloric acid or hydrogen chloride, that's the name, we will do the exact same thing. So we have a hydrogen bonding to a chlorine. The change in En is equal to, now we look, 3 and 2.1. So 3, 0 minus 2.1. And the answer is 0, 9. Now 0, 9 also falls in this region, which means that it is a weak polar covalent bond. All right. So now I'm going to do the last example, which is ammonia. So just for some reference from grade 10, NH3 is called ammonia. NH4 is an ion, and it's an ammonium ion. So we have ammonia and ammonium. All right, so let's get into calculating the electronegativity difference for ammonia. So I'll start off by saying the change in En is equal to, now remember, this is the compound, but it's a H bonding to an N, and there's 3 of them. So if I were to draw the Lewis dot for this, it would be N. So remember that nitrogen is in group 5. I just want to draw it nice and clear. So it's in group 15, meaning it has 5 valence electrons. And then I have hydrogens right around it like this. And then there's a lone pair on the top there. So the bonds you can see are here, the shade pairs. It is between an H and an N. So I'm going to my table. Nitrogen is 3, 0 minus my hydrogen is 2, 1. And that gives me an answer of 0, 9. Now, just to do one more example, I'll just write it over here. CH4, which is methane. You're looking at the molecule, right? So it looks something like this. There's a carbon with 4 hydrogens around it. So if I were to calculate the electronegativity for methane, it would simply be as follows. The change in En, and I have a carbon which is 2.5 and then hydrogen which is 2.1. So it'll be 2, 5 minus 2.1, and that should give you 0, 4. So the type of bond here would also be a weak, we don't use moderately in South Africa, we say it's a weak polar covalent bond. So in conclusion for this segment, what you need to understand is that the electronegativity range or difference, this table, is of utmost importance when calculating electronegativity difference. So you need to know this table and memorize the range as well as the type of bond. Alright, so lastly, I'm going to do polar and ionic, and hopefully you'll be able to do electronegativity differences. I'm going to calculate the electronegativity difference for polar molecules. So first up we have H2O. That's water, and we know that water, the change in En, it's between an H and an O. So I'm going to look at oxygen, which is 3, 5, and hydrogen, which is 2.1. So 3, 5 minus 2, 1, and that should give me a nice 1, 4. All right, so that would be a polar covalent bond because it falls in this range between more than 1 but less than 2. All right, another example is HF, hydrogen fluorine, which you can see here in the examples is 1,9, making it a polar covalent bond. All right, the last example for polar covalent bond that I'm going to be using is the CF3. All right, so for this one, or CF4, there's a C-F bond, and that's for both molecules. And what will happen here is I'm going to say the change in En, the change in electronegativity is I have a 4,0 minus carbon, which is a 2,5, and that would give me 1. So that would give me an answer of 1,5, which is also in the range here, which makes it a polar covalent bond. All right, so that's it for that. Right, the last type of electronegativity difference are examples for ionic bonds. All right, so I'm going to use the classic NaCl. We know that this is a sodium ion, a cation, and a chlorine anion. So to find the En difference, I will simply say that I'll go to my table and find that chlorine is 3,0 minus, for sodium it's 0,9, and my answer for this would be 2,1. So you can see here anything that is greater than 2 is considered an ionic bond. So the bond polarity for NaCl is ionic, and it has an electronegativity difference of 2.1. Our next example we're going to look at includes sodium once again. It's sodium bromide. So I'm going to say sodium bromide, and that is obviously a bond between Na plus and Br minus. These two are ions. The electronegativity difference is equal to, I'll see that bromine is 2,8 and sodium we know is 0,9. The difference there is 1,9. So this is also an ionic bond. All right. Now, if there's a compound, now these don't have any subscripts. So if there is a subscript, we have to do something else. All right, so let's have a look. We have magnesium chloride. Now, in this case, you have 2 chlorines bonding to 1 magnesium. So there is a Mg bonding to a Cl. That's the 2 of those bonds exist, or the transferring of electrons happens there. Now, to find the En difference, we will say magnesium is 1,2 and the chlorine is still 3. So 3,0 minus 2,1. That's 1,2. 1,2 would give me 1,8, and because that is greater than these values, we will say that it is an ionic physical science bond. Help, like this video, so comment down below if you have anything to say to me. Electronegativity difference and you are able to calculate it. Please do subscribe to my channel. Comment down below and like this video so that it can be shared with other learners who need